in just a few minutes here, I'm going to show you a quick little demonstration I was able to do in my classroom just a few minutes ago. So to start off this reaction, I placed 200 milliliters of distilled water in a 400 milliliter beaker, placed just a few flakes of sodium hydroxide into that solution and mixed it for a few minutes until it was completely dissolved. And then I added about 5 to 7 maybe drops of 0.1 molar potassium permanganate solution just to get it that nice purple color to start off with. This is an alkaline solution because of the hydroxide ions that are going to be floating around in there. This is a great example of a redox reaction, and just a reminder, a redox reaction is any chemical reaction in which a molecule, atom, or ion loses or gains electrons, which alters the oxidation states. An oxidizing agent will gain electrons and is therefore reduced in the reaction, while a reducing agent will lose electrons and is therefore oxidized in the reaction. In the experiment you're about to witness, glucose from a lollipop is used as the reducing agent. And I want to clarify that. We could have used glucose. I believe the actual chemical in this reaction will be fructose, and fructose therefore will be the reducing agent. It's a slight variation on the glucose compound. All right, so let's watch to see what happens along with a little bit of an explanation to explain what you're seeing. All right, the first color that you're going to see is going to go from this pink color to a darker purple color, will correspond to permanganate ions, again MnO4-, and manganese in that reaction should have an oxidation state of +7. So again, we're going to see it go from like a pink color to a nice purple color. The permanganate ions, MnO4-, will then be reduced to manganate ions, which is MnO4 with a 2- charge. The oxidation state of manganese will change from +7 to a +6, and the color should change from purple to green. As we were watching that, you kind of saw an intermediate blue stage that occurred between steps 1 and 2. One explanation for that is that the mixture contains both purple permanganate and the green manganate ions, which will combine to produce a blue solution. Another explanation that is given in the literature is that a part of permanganate is reduced to hypomanganate, MnO4 3-, which has an oxidation of +5 and a blue color. So a couple of different explanations to account for that blue intermediate color that we saw. The manganate ions, MnO4 2-, have an oxidation state of +6, will further be reduced to manganese dioxide, so MnO2. And the manganese in that state will have an oxidation state of +4, causing an additional color change from green to a yellow-brown color. Finally, when even more glucose or fructose is incorporated into the solution, a brown-black manganese dioxide will form a suspension in alkaline solution, and because this solution is fairly dilute, it will appear orange. I'll be really honest with you, you can kind of see all of the different particles floating around in there. It was really apparent to the naked eye without the camera in front of it, and to be honest, looking at the picture right now that I'm seeing on this video, it does not look nearly as orange on camera as it did in person. In person, it actually looked quite orange, and you could look and you would see the colloid suspended in that solution. All right, we'll go ahead and pause that. There are follow-up questions to this video, so if you guys could jump on that document and go ahead and complete the post observations discussion questions, that'd be awesome.